you for that fabulous introduction. As they just said, I'm Sandi Barr. I'm a senior software engineer in my day job at PRX, and we work to promote diverse voices in audio through our public radio and podcast distribution platforms. I also work with a nonprofit called Mystery Code Society, and our mission is to promote gender equity in tech for women, femmes, and non-men by providing them coding education. And I'm starting a Women Who Code network in Omaha, so I'm kind of doing a lot. But anyway, today I'm here to tell you about a framework I've used for Redux style state management in Angular with TypeScript called Ngrx. It leans a lot on concepts from functional reactive programming, which is this whole idea in software development that says entire programs can be built on the notion of streams. So this development style consists of identifying the streams of values that your program is interested in, combining them together, and finally subscribing to those values to produce a reaction to new values. The main idea here is to build programs in a declarative-only way by defining what are the streams, how they're linked together, and what happens if a new stream value arrives over time. You can then listen to those application state streams and react accordingly. Programs such as this can be built with little to no application state variables, which are in general a source of errors. The application does have state, but that state is typically stored on certain streams, not on the application code itself. Ready to learn more? Cool, I'm gonna walk you through it. So what are these values on the streams that we're talking about? What do they consist of? Things like your event buses or your typical click events that happen in your web applications are really just an asynchronous event stream on which you can observe and then do some side effects. Anything can be a stream. User inputs, variables, caches, data structures, etc. A stream is just a sequence of ongoing events happening over time. It can emit three different things: a value of some type, an error, or a completed signal. We capture these emitted events asynchronously by defining a function that executes when a value is emitted, another function when an error is emitted, and yet another on complete. A Redux store is a combination of the command and the observable patterns. What we do with the store is we send it a command object known as an action. We dispatch an action into the store, and the store will operate on that data inside the store. But the emitter of the action does not know what the store is going to do with it. The consuming components have subscribed themselves to the store like if they had subscribed to just an RxJS observable. This pattern works really well because we would have to then go out of our way to turn that emitted data into a command. We keep our components clean and decoupled from what's going on in the store. We should design our actions then as events on a stream. A single action describes an event that has just happened in the very recent past. Our component views then only need to describe the various application states, those being values, maybe waiting on events or values, errors, etc. So in functional reactive programming, you should have a tool set to create, combine, filter, and work with these streams. In Angular, that tool set is RxJS, the reactive extensions library for JavaScript. RxJS observables give us all sorts of ways to take advantage of these streams. A stream can be used as an input to another one. Even multiple streams can be used as an input to another stream. You can map data values from one stream to another. You can merge two streams. You can even filter a stream to produce a new stream that has only the events that you are interested in. In Angular, when you have a piece of data that needs to be used in multiple places in your app, we can just use dependency injection and create a service with observables to manage and communicate changes to our application data. There's really nothing wrong here with global state. Some user data maybe is needed everywhere. Why not load it once and just put it in a singleton service? Dependency injection can inject services deep in the component tree, can even inject components and services into each other, and can create shared data services that may or may not store that data. Sometimes, though, when we try to solve these problems with event buses, we can easily find ourselves in event soup scenarios, where the events can chain themselves together in complex and unexpected ways, and it can become very hard to reason about the application. This is because an event can, as we said, very easily be turned into a command, causing the emitter to know about the internals of the receiver, so our components and services become coupled. Plus, there is the possibility of chaining those events together accidentally. As a lot of the React developers in the room may know, that unidirectional data flow can make things easier and predictable and more easy to follow. But is decoupling then what happened from how things are supposed to change always a good thing to do? No, it's often a trade-off in indirection and boilerplate code. So why use Redux-style store state management at all? Well, unless there's a concurrent data modification scenario or the need to combine multiple complex streams of data, we should consider starting to build our application with some plain RxJS services, leveraging those local services and the dependency injection system. Then if the need arises, we can always refactor into a store. So what about this Ngrx boilerplate? In Ngrx, the boilerplate consists of the application state described as plain objects and arrays, and it describes changes in the system as plain objects, and it describes the logic for handling those changes as pure functions. Additionally, using Redux-style state management with TypeScript gives you safety against typos, increased refactorability, and self-documenting code. For teams of developers, boilerplate is a good thing if you're not working in a vacuum. And indirection is now a term for abstracting things so that as they get more complex, you can break them off into their own files in an organized and consistent pattern. It's not so much of a bad thing. So how do we then get started using Ngrx? We'll use the CLI to scaffold our application. We can go from newing up an app to hooking up our root state in a few short commands. We'll add Ngrx core, store DevTools and effects to our dependencies, and Ngrx schematics to our dev dependencies. Configure the CLI's default collection to Ngrx schematics, and then we can just generate our root store and effects with those schematics, and we're off to the races. The next thing we need to do is set up our feature. We'll need a feature module and a model. So we're thinking like, what does our application do? What data does it need? In most cases at my work at PRX, for example, I usually start out working with a collection of podcasts that have a number of episodes. So that's going to be the basic example that we'll work from today. The action generator gives us a framework to create our actions. It assumes to get started, you're loading a collection of whatever action name you gave it. I like to use that group option to group my action files within a folder because I think that keeping your actions grouped together is nice because they provide a good reference to the whole part of the whole application. When loading our collection from an API, we need to handle this asynchronously. So we're also going to add a success and a failure action for handling possible responses from the server. Here we're using a string enum for our action types to provide type safety with TypeScript's compile time checking. Enums make it easier to document intent or create a set of distinct cases. TypeScript introduced support for enums in version 2.4. In a string enum, each member has to be constant initialized with a string literal or with another string enum member. Another way to declare our strongly typed actions that actually results in a lot of exports is just declare them as constants. We capitalize the constant to avoid collisions with two similarly named exports, the action type and the action creator class. People often will capitalize both sides of the const name and value. Good action hygiene says that we should also include the source of the action, in this case, the API name, to give us more context in those dev tools and such. Another way then to declare these actions is by setting up a const object with properties as your action types. But now string enums exist. With the TypeScript 2.4 release notes actually saying, having had some time to see how these features were being used, I literally feel seen as an Ngrx user. So back to our action creators then. An action consists of a type and usually has a payload. At the top, we've got load podcasts. That's just the request for loading the collection. We'll instantiate and dispatch that action to get our podcast records loaded. The load podcast success and load podcast failure are the potential responses and we'll mostly act on those in our reducer. Load podcast success has a payload of podcasts that we'll use to populate our state. And usually our failure actions have a payload containing an error. We're just using any here for convenience. In a typical CRUD app, we'd also be creating add podcast with update podcast, delete podcast, all those actions, along with success and failure for each. What we're building here with these action creators is an advanced pattern for type narrowing called discriminated unions, which are very useful in functional programming. In TypeScript, you can combine singleton types, union types, type guards, and type aliases to build these discriminated unions, which consist of types that have a common singleton type property, the discriminant, a type alias that takes the union of those types, the union, and type guards on the common property. In our case, the discriminant is the read-only type property that all of our action creator classes have. And we're exporting our union type alias podcast actions here at the bottom. In our reducers, we will use these type guards to narrow the types to their individual action classes so that we can access the specific payloads to apply those changes to the state. One thing I do want to mention here with the discriminated union pattern that I've run into at times is that I've honestly had some kind of weird issues with how string literal types are narrowed. I've been in situations where I need to wrap my cases in additional type guards for some reason, so I think we should talk about what those are. A type guard is some expression that performs a runtime check that guarantees the type in some scope. TypeScript will realize that the object must be of the type that has the specific literal and do a type narrowing for you. The different types of type guards are a switch on the discriminant, type of, where type of is either equal or not equal to a primitive type name, and then there's instance of, which narrows types using their constructor function. Most commonly, you'll see that first one, a switch on the discriminant in your reducer functions. With the discriminated union, we shouldn't need to use those other type guards in our app because we're only accessing those action properties when created via their constructor functions and in the switch cases in our reducers. When adding new types, an additional thing that can help TypeScript to tell us where we are missing support is by using exhaustive checks. Unpopular opinion here, maybe, TypeScript can be a little less annoying when it's being helpful. There are a couple ways to do this. We can turn on strict null checks and specify a return type in our switch case reducer functions, so when the case falls through, the function returns undefined and TypeScript doesn't allow it. This method, though, can actually be quite subtle, and besides strict null checks doesn't always work with old code. It is what I'm most used to, though. More explicitly, we can use the never type in our fall through to have our code throw a compile error when the match type falls through. Never in TypeScript is this concept in programming languages when they do code flow analysis, and it represents stuff that just might never happen. If using strict null checks and doing explicit exhaustive checks, be sure, though, to return that exhaustive check in your default case. Otherwise, TypeScript is going to infer a possible return of undefined. I mentioned TypeScript can be a little annoying sometimes. So then next in the chain, we've got Ngrx effects. The basic gist of Ngrx effects is that it provides an API to model event sources as actions. Our Ngrx schematics generator hasn't really given us much here to start with, but it will start us off with an injectable class with an actions observable. You can use the module or root options to register the effect for feature or for root with the appropriate feature or root module. Similar to the action we just generated earlier, you can also use that group object to group your effects into a folder. Before we get too far into it, let's talk about how to use these effects appropriately and what is and is not a side effect. Changes on the server and the response to the client is a side effect. When a user submits a form, we need to make a change on the server. The change on the server and that response is a side effect, an asynchronous event outside our control. Needing to fetch data from the server is also a side effect. When a component needs data, You can use an effect to handle the component's action to fetch that data, resulting in a subsequent action with the data to be consumed by the store, then reacted to by the component. Cool so far? In a more complex scenario then, when a component needs data to be fetched that depends on other data that also needs to be fetched from the server, we can use an effect to create a complex stream with nested actions depending on another action. This is where the real magic of effects comes in. In our effect for the dependent action, we retrieve the part of the state that we're dependent on and merge that stream with the action stream to then go fetch that dependent data. Seems pretty straightforward, right? So what's not a side effect? How can we abuse these? Duplicate or derived state is not a side effect. Don't abuse effects as a way to handle that derived state. We do want to consider application views as we build up our state tree, but we should be looking to selectors to transform our state into those application views, and we will see that down the line. Duplicating actions to couple actions with reducers is also not a side effect. Let's say we've got a collection. If one of the records is removed from the store, we'll also want to make sure to remove and clean up any child records, right? So instead of abusing effects to duplicate the action for the child reducer, the child reducer should just respond to the original remove parent record action. Generally, I think of the purpose of actions as decoupling what happened from how state is supposed to change. What happened was delete parent record success. It's the job of reducers to cause the appropriate state change. So let's take a look at an effect for fetching data. Our effects looks for actions of a certain type, load podcasts, then calls to the service to request the records and responds asynchronously with either success or error as a failure action. So this is pretty magical. We can add RxJS start with operator to trigger the effect immediately upon startup to hydrate our app. How about that? Effects drive many of the things that happen in our applications. Once our effects are set up to receive our actions and respond asynchronously with the server response, we can move on to handling actions in our reducers to create state. With Ngrx schematics, we'll get a skeleton reducer with a state interface, our initial state, and the reducer function with our switch type guard. We want this podcast reducer registered with the podcast module and added to our root reducers. And we're going to group our reducers again in a reducers folder. When we initialized our root state, way back in the beginning when we initially generated our store, we got this action reducer map that provides for added type checking on our state. How this works is we have a root state and a root reducer. You will access then slices of state with selectors that reveal parts of or combine multiple slices of the feature states. The action reducer map that the Ngrx framework provides registers the reducers and then it is configured in the application module. This here is the glue that gets the actions applied to the reducer functions and exposes the resulting state. So now that we've taken that long way around and talking about all the things involved in getting set up to build our state, I'm going to show you a shortcut to adding feature state with Ngrx schematics. So whether you opt to go one step at a time to generate the action, effect, and reducer skeletons, or cut to the chase and head straight for generating your full feature, you'll end up right about here. You've got your feature module. And then you can add the action, effect, and reducer skeletons in one step with ng generate feature. It helps take a lot of the guesswork out, which is fine now that you totally know where we're going, right? So what's our state going to look like? It's a collection of podcast entities, loading status, potentially an error. Our initial state initializes the entities, loading, and loaded. But what is that entities? It's an object with IDs mapped to the entries of the collection. The entity pattern is used to avoid deep setting by creating shallow data structures that are optimized for find by ID queries. It can be important to remember that object property order is not guaranteed in JavaScript, so you may need to consider additional ways to maintain the order of your collection, such as an ordered array of IDs, for example. And then in our reducer functions, when we load our podcasts, we are in a loading state, so our reducer acts on the load podcast action by setting loading to true. If an error occurs, we respond to load podcast failure by setting the error from the payload. And then when we get the success action, we are no longer in a loading state. And, just like set our entities by reducing the actions, payloads, podcasts onto the existing state podcast entities. Looks pretty simple, right? Don't worry too hard about it right now. Ngrx got you on this one. To handle add and update actions, we do just add or update the entity in the collection by ID. And this is cool. At least for me, I still get excited about ES syntax that makes things a lot easier for me. So for delete, we use destructuring to assign the entity with the deleted ID to removed and the rest of the entities to the entities const. So I might have tricked you again going the long way around. Remember how with the feature schematics, we can get the action, effect, and reducer skeletons in one go? We can reduce the state management boilerplate for collections even further using the Ngrx entity adapter. Ngrx entity is an entity state adapter that provides an API to manipulate and query entity collections. By using the schematics generator, we'll get our model, actions, and reducers with selectors all hooked up with fully featured entity adapter collection API. Here's, in this example, we're going to use it to add an episode collection to our podcast module. The generated episode model will just have an ID property to start, but then we can add other properties to it, such as the GUID, the corresponding podcast ID, a title, text description, and say a date the episode was published that will all be passed along with the entity in our collection. The entity collection API supports all CRUD actions: loading, add, upsert or update, and deleting one or a set of records. The entity adapter collection methods can also change one-to-many entity records at a time. Each method returns the newly modified state if changes were made and the same state if there were no changes. Since most reducers that manage the state of entity collections end up looking just about the same, using this Ngrx entity adapter goes a really long way towards reducing the state management boilerplate. The entity adapter is made to work with your model and can take two properties: the select ID for selecting the primary ID for the collection. In our case here, we want to use the episode GUID. And we're also providing a sort comparer function. The sort comparer function is only needed if the collection should be sorted before being displayed. You can explicitly set the sort comparer to false to leave the collection unsorted, which will be more performant with CRUD operations. What we don't get here, though, is the entity effects for managing asynchronous interaction with the API to say, like, get that list of episodes for each podcast. So in order to fully hydrate our application, we want to load episodes for each podcast after we have the podcast loaded. So we'll generate an effect class to which we inject our service and an effect dependent on load podcast success in order to request loading of each podcast's episodes. Merge map produces a stream of add episode actions, one for each podcast, which we transform into an asynchronous action to request loading of episodes by their podcast IDs. Next, we'll create an effect to call the service for loading a set of episodes by that podcast ID. In our application, we are requesting the loading of many podcast episodes at a time. So in this effect, we use concat map because it waits for each observable to finish until the next one is processed, preserving the order of the podcast array and requesting each podcast episodes in succession. In many of our asynchronous load actions, we would use switch map in this place in order to cancel and replace the prior observable with a new one. We often use switch map in order to cancel duplicate requests, which is not what we're looking for here. It's an important difference that you're going to learn when working with RxJS and effects. So I hope you are starting to see here how all of these Ngrx reactive libraries for Angular work together to build our application streams. They've really done a lot of work to recognize the common problems that we encounter as developers and provided libraries to handle them. So now then, after all that talk of the different ways to set up our Ngrx store state, no matter which schematics generators we use or if we choose to use that initial manual setup we were discussing, we're going to be right here, the place where our actions, effects, and reducers are managing state. We're at the point of wanting to expose that state to our views, and we're going to create selectors to derive it from our stores. Selectors are pure functions that take slices of the state as arguments and return some data that we can pass to our components. If we perform this data transformation from within the Ngrx store by composing selectors to return just what we need, we can keep our components lean and decoupled from the store. So first, we will define some helper functions to access the different parts of our podcast store state. When using Ngrx entity, these helpers and more are provided for us. We'll use create selector from the Ngrx store to create memoized selectors that are only recomputed when the arguments change. We've got a feature selector on the podcast state, a selector using our get entities helper, and finally a selector that returns an array of podcasts. This is the one that we'll be using to provide the collection to our components. In our application, we want to show a list of podcasts with their episodes, so we'll compose a selector that combines them. First, we define the episode feature selector, then use the provided select all helper from the episode store's Ngrx entity selectors. Then we can combine our podcast episodes entities with the episodes filtered by the podcast ID to produce a podcast array in the state in the desired view shape. So are we there yet? Yeah, we're here. We've finally gotten through all the state setup, and we're going to talk about showing it off in our components. First, we've got smart or container components that should be at your root level, typically your routable components. These components generally have direct access to the Ngrx store or a derivative. Smart components handle view events and the dispatching of actions, whether through a service or directly. Smart components also handle the logic behind events emitted up from child components from within the same view. The async pipe is meant for handling both observables and promises. You can pipe any observable or promise through the async pipe, and a subscription will be created, updating the template value when a new event is emitted from the source observable. This pipe also handles unsubscribing from the supplied observable, saving you the mental overhead of cleaning up subscriptions in ng on destroy. In a store application, you're going to find yourself leaning on the async pipe heavily in nearly all of your container components. Also worth noting here is that we're setting up our observable on the selector in on init rather than in the constructor. And why is that? The constructor on an ES6 or TypeScript class is a feature of the class itself. It's not an Angular thing. So Angular has no control over when the constructor is going to be invoked. Our input bindings, for example, are not available in the constructor for this reason. So we use the constructor for dependency injection, but as a general rule, on init is for initialization. Then we've got our dumb or child components that are generally for presentation only. They rely exclusively on input and output parameters, and then when relevant events occur in these dumb components, they are emitted up to be handled by the parent smart component. These presentational components will make up the majority of your application, as they should be small, focused, and reusable. These components aren't aware of the Ngrx store or state management, but it's totally reasonable and expected for them to have some internal state, such as like it's open for a dropdown. Then with Ngrx store DevTools installed and the Redux DevTools browser extension, yes, the same one you'd use on plain Redux apps, we can view the action log to give us an understanding of how an application works and what parts of the application are triggering actions. And we get the state inspector for inspecting the in-memory state, and a time-traveling debugger that allows us to replay actions, and if we add the Ngrx router store, we can replay the whole session navigating through various screens of the application. DevTools gives us immediate visual feedback about what an application is doing, making it much easier to understand. So I want to thank you all for listening to my talk, and I especially want to thank our organizers and volunteers and MCs for putting on this amazing event for us, and I can't wait to party with you all tonight. That's all I have.